You need to watch this. In the vast, silent theater of the cosmos, a new actor has just taken the stage. It's a fleeting performance, a visitor from an unknown place, moving with a purpose we are only just beginning to understand. If you've ever struggled with spotting the subtle wonders of the night sky, or felt that the universe's greatest secrets are hidden from view, this one's for you. It's a story that connects the patient work of astronomers with the deepest questions we have about our place in the galaxy. This one's a real head-turner, but to appreciate why, we first need to understand what makes it so special. For nearly all of human history, everything we studied in the sky, planets, comets, asteroids, belong to our own solar system. They were our celestial family, born from the same cloud of gas and dust, gravitationally bound to our sun. We thought we were alone, in a cosmic sense, but in 2017, that changed forever. Astronomers detected an object named Oumuamua. It wasn't orbiting our sun, it was just passing through. Its trajectory proved it came from interstellar space, the void between the stars. It was the first confirmed visitor from another star system. Then, in 2019, came 2I Borisov, a second visitor that looked and acted much more like a conventional comet, giving us our first real taste of the chemistry from another solar system. These objects, known as interstellar objects, or ISOs, are cosmic messengers. They are fragments of distant worlds, ejected from their home systems by gravitational chaos, and sent wandering through the galaxy for millions or even billions of years. And now, we have a new one. Scientists call it 3I Atlas. The 3I designates it as the third confirmed interstellar object. The Atlas part comes from the system that found it, the Asteroid Terrestrial Impact Last Alert System. This isn't one giant telescope, but a network of robotic observatories in Hawaii, Chile, and South Africa. Their primary job is to scan the entire night sky, searching for asteroids that might pose a threat to Earth. Every night, these telescopes generate a torrent of data. Sophisticated software sifts through millions of points of light, flagging anything that moves or changes brightness. On a routine night, an automated data pipeline flagged a faint, unassuming dot moving against the background of stars. At first, it was just another designation, another object to be tracked, but as more observations were collected over the following days, a startling picture began to emerge. It was first flagged by these telescopes, but the real work began with the follow-up. Alerts went out across the global astronomical community. Telescopes, both large and small, amateur and professional, swiveled to get a better look at this new arrival, to confirm what the initial data was suggesting. And what it suggested was something hyper-speedy on a slingshot path through our neighborhood. The object was moving far too fast to be gravitationally bound to our sun. It was a tourist, not a resident. Its trajectory? Hyperbolic. In orbital mechanics, the shape of an orbit is defined by a number called eccentricity. A perfect circle has an eccentricity of 0. The elongated ellipses of planets and comets have an eccentricity between 0 and 1, but this object's path had an eccentricity greater than 1. That's the mathematical signature of an interstellar traveler. It means the sun's gravity can bend its path, but it can never capture it. Meaning it came from another star system. It fell towards our sun from the direction of the constellation Aquila, accelerated as it passed perihelion, its closest point to the sun, and is now heading back out into the galactic dark, never to return. And it won't stick around. This fleeting visit is our only chance to study it. Every photon of light collected is a precious clue to its origin and nature, and the clues we're gathering are painting a very strange portrait. Its shape and behavior. Odd. Very odd. This is where 3I Atlas starts to get truly fascinating, and where it departs from our previous interstellar guests. It's not a comet. At least, not a typical one. When a comet from our own solar system gets close to the sun, its ices sublimate, turning directly from solid to gas, creating a glowing atmosphere called a coma, and often, a spectacular tail of gas and dust. 2I Borisov did this. It was clearly an active comet, rich in familiar volatiles like water and carbon monoxide. But 3I Atlas has no typical comet tail. Despite its close pass by the sun, it remained stubbornly inert, showing no signs of the widespread outgassing we'd expect from a classic icy body. This suggests it might be made of denser, rockier material, or that its surface volatiles were burned off long ago, and it's not an asteroid, or again, not a typical one. While it lacks a tail like an asteroid, its other behaviors don't quite fit. This is where the mystery deepens. It has a highly unusual light curve. A light curve is a graph of an object's brightness over time. For an asteroid, this variation is usually caused by its rotation, as different sides with different shapes and reflectivity face us. The light curve of 3I Atlas is erratic. It doesn't show a simple periodic tumble. It suggests a complex shape, or perhaps something more is going on. And then, there are the brief outbursts. While it lacks a persistent tail, telescopes have recorded sudden short-lived increases in its brightness. These aren't the sustained fireworks of a comet, but more like brief, localized eruptions. What could cause this? Perhaps pockets of highly volatile ices, like frozen nitrogen or carbon monoxide, trapped beneath a rocky crust, are bursting out as they're heated by the sun. This could be a Manx comet, a rocky body with cometary origins, or something entirely new. These conflicting signals are what have astronomers scratching their heads. It has the trajectory of an interstellar object, the inertness of an asteroid, but the sudden outbursts of a comet. It's a hybrid, a chimera, a puzzle sent from another star. But before you shout aliens, and with an object this strange, the thought is tempting. It's crucial to understand how science confronts the unknown. The story of Oumuamua was dogged by speculation about its artificial origins, partly due to its unusual acceleration away from the sun. Remember, science starts with data, not drama. The burden of proof for an extraordinary claim is extraordinary evidence. To even begin to entertain an artificial origin, we would need to see things that natural physics cannot explain. This could be radio transmissions, evidence of non-gravitational maneuvering that isn't caused by outgassing, or spectral data showing processed, unnatural materials. So far for 3I Atlas, we have none of that. Every strange behavior, while puzzling, still falls within the realm of plausible, if exotic, natural phenomena. Instead of jumping to conclusions, teams are running spectra. This is one of the most powerful tools in astronomy. By splitting the faint light from 3I Atlas into its constituent colors, like a prism, scientists can look for the chemical fingerprints of different elements and molecules. They're searching for the signatures of water, silicates, carbon compounds, anything that can tell us what this object is made of, and compare it to the building blocks of our own solar system. They are meticulously tracking its motion. Every new position measurement, or astrometry, helps refine our understanding of its orbit. This allows scientists to calculate if there's any non-gravitational acceleration, a tiny push that isn't caused by the gravity of the sun and planets. For a comet, this push comes from outgassing acting like a weak rocket engine. For 3I Atlas, detecting such a push, and correlating it with the observed outbursts, would be a huge piece of the puzzle, and they are constantly comparing models. Is it a nitrogen iceberg chipped off a Pluto-like planet in another system? Is it a dry, rocky fragment from a planetary collision? Is it an ancient dormant comet whose surface has been processed by eons of cosmic ray exposure? Each model makes predictions, and each new piece of data helps us rule some out and strengthen others. A spacecraft won't chase it. It's moving too fast and was detected too late for us to mount a mission. But our telescopes will. From large ground-based observatories to space telescopes like Hubble and Webb, the astronomical world is pointed at this fleeting visitor, squeezing out every last drop of information before it vanishes back into the interstellar night. Ultimately, 3I Atlas is a reminder. It's a tangible piece of another solar system, delivered right to our doorstep. Studying it is a form of galactic archaeology. It tells us about the processes of planet formation and the diversity of worlds that exist beyond our own. The fact that we've now found 3 of these objects in just a few years, with technology that is still in its infancy, suggests the galaxy is teeming with them, and this is just the beginning. Soon the Vera C. Rubin Observatory in Chile will come online. It will survey the entire sky every few nights with unprecedented depth and speed. It's predicted to find not 1 or 2 interstellar objects per year, but dozens. We are standing on the precipice of a new era of interstellar astronomy, where these visitors will become a regular part of our cosmic landscape. The universe sends postcards, and we are only now learning to read them. Each one, whether it's a familiar-looking comet like Borisov, a bizarre enigma like Oumuamua, or a puzzling hybrid like 3-Eye Atlas adds a new word to our cosmic vocabulary. The science is ongoing, and the story is still being written. Follow for updates as astronomers untangle this incredible mystery. Because with a whole galaxy of worlds to draw from, the next mystery to arrive could be even stranger.